Hello, my name is Adrienne Wallace, and today I will be discussing transforming teaching, engagement, and experiential learning with AI, gamification, and extended reality in education. I will give a detailed analysis of AI's transformation of teaching practices, augmented reality, mixed reality, and virtual reality combined with gamification in education. I will examine how AI is transforming instructional practices and how immersive technologies, augmented reality, mixed reality, and virtual reality, when integrated with gamification, are creating more engaging, personalized, and future-ready learning experiences. Let's begin with defining what is artificial intelligence. Artificial intelligence is the ability of computer systems to perform tasks that typically require human intelligence. AI allows machines to learn, think, and make decisions based on data. AI is rapidly reshaping the educational landscape. Once considered a futuristic concept, AI has moved from research laboratories into everyday classroom tools. From generative text models and adaptive learning platforms to AI-driven multimedia creation and automated feedback systems. AI is influencing how educators design instruction, how students engage with content, and how learning resources are produced and distributed. The integration of AI into teaching is not merely a technological shift, it represents a pedagogical transformation. AI is altering the role of the teacher, redefining instructional design practices and expanding the accessibility and scalability of open educational resources. While AI introduces opportunities for personalization, efficiency, and innovation, it also raises concerns about ethics, equity, cognitive dependency, and instructional integrity. From generative text models and adaptive learning platforms to AI-driven multimedia creation and automated feedback systems, gamification is the art of applying game design elements to non-game contexts, making everyday learning more dynamic. But when you step into extended reality, gamification becomes truly immersive and interactive. Think about experience points, levels, and progression systems that track your growth in real time. Imagine earning badges and climbing leaderboards as you master new skills within a virtual environment. Or being guided by narrative storytelling, missions, and quests that turn lessons into adventures. These elements don't just teach, they engage and inspire students in ways we've never seen before. Beyond the technology itself, XR has a profound impact on our minds, often inducing a state of deep flow. In this state, distractions fade away, replaced by high focus and a powerful sense of intrinsic motivation. Immersive experiences also create stronger emotional memory encoding, which significantly improves long-term retention. And through embodied cognition, physical interaction within XR strengthens learning by engaging the body and mind together. By tapping into how our brains actually learn, XR is making education more memorable and effective than ever before. In career and technical education, XR is a game changer, mirroring real-world tasks like virtual welding simulations. From AR auto repair overlays to gamified cybersecurity challenges, it creates a safe space for hands-on mastery. For history and social studies, we can now step into immersive simulations and role-play civic decisions. These gamified quests allow students to experience history firsthand, making the past feel truly alive. XR also offers vital support in special education, providing controlled VR environments for social skills training. With AR scaffolds for executive functioning, we're making learning more accessible and inclusive for everyone. Whether it's vocational skills or historical adventures, XR is opening doors to a world of limitless potential. When we layer gamification onto extended reality, the impact on learning outcomes is profound. First, we see a significant boost in engagement and motivation. Students aren't just watching, they're participating. This immersion naturally leads to increased time on task, as the learning experience becomes captivating rather than a chore. Finally, it fosters a mastery orientation. Students are encouraged to try, fail, and try again until they succeed. By combining XR with gamification, we're building a learning environment where every student is driven to excel. In STEM education, VR labs allow students to conduct complex experiments without the physical risks or high costs. AR overlays provide real-time support for problem solving, while gamified engineering challenges keep students persistent. The healthcare sector is also seeing a massive shift, with VR surgical simulations and MR anatomy overlays. These technologies, combined with scenario-based gamified patient interactions, are training the next generation of doctors. From STEM to healthcare, the fusion of XR and gamification is truly redefining what it means to learn and grow. First, we'll look at personalization and adaptive learning. One of the most significant contributions of AI to teaching is the ability to personalize learning experiences. Traditional classrooms often rely on standardized pacing and instruction, which may not meet the diverse needs of learners. AI systems can analyze student performance data to adjust difficulty levels, recommend targeted practice, and provide individualized feedback. Adaptive learning platforms use algorithms to achieve several key instructional goals. First, they identify knowledge gaps by analyzing individual student performance. They also modify task complexity to keep learners in their optimal challenge zone. The systems adjust pacing, allowing students to spend more time where needed and move ahead when ready. And finally, they recommend supplemental materials to further support the student's unique learning journey. These combined features create a truly responsive and personalized educational environment. This form of personalization aligns with Vygotsky's concept of the zone of proximal development, as AI can provide scaffold support tailored to each learner's readiness level. By dynamically adjusting instruction, AI supports differentiated learning environments and can improve engagement and retention. However, personalization must remain pedagogically intentional. Without thoughtful integration, AI-driven adaptation may reduce opportunities for productive struggle or collaborative learning. Next, let's look at the automation of routine instructional tasks. AI significantly reduces the time teachers spend on repetitive administrative and production tasks. Educators can use AI tools to draft lesson plans, generate assessment questions, create rubrics, and summarize readings. They can also use AI to convert text into multimedia and even automate grading for objective assessments. By automating these routine tasks, AI allows educators to focus more on mentoring, student engagement, and higher-level instruction. This automation allows teachers to redirect time toward higher-value activities such as mentoring, feedback conversations, and instructional refinement. The significance of this transformation lies not in replacement, but in augmentation. AI becomes a productivity partner, enabling teachers to focus on human-centered aspects of education that machines cannot replicate. This expansion of multimedia capabilities supports Meyer's cognitive theory of multimedia learning, which emphasizes the benefits of combining visual and auditory information to enhance comprehension. AI-driven multimedia tools reduce barriers to entry for educators, enabling richer and more engaging instructional materials. However, design principles must guide multimedia use to prevent cognitive overload or superficial engagement. Immediate feedback aligns with formative assessment theory, which emphasizes timely intervention to improve learning outcomes. By shortening feedback loops, AI increases opportunities for iterative learning and mastery. However, the quality of AI feedback depends heavily on instructional design oversight. Educators must verify accuracy and ensure that feedback promotes critical thinking rather than passive correction. XR creates immersive environments that naturally increase motivation and participation. Next is retention. Research shows that immersive experiences lead to stronger memory encoding. Then there's skill transfer. Realistic simulations allow for immediate application of knowledge. Safety is also key, providing a risk-free space for experimentation and learning from mistakes. XR promotes equity by giving access to experiences that might otherwise be out of reach for many students. And finally, workforce readiness through industry-aligned simulation training that prepares students for the future. The future of learning is immersive. While XR and gamification offer incredible potential, we also have to navigate some real-world challenges and limitations. First, there's cost and infrastructure. VR headsets and mixed reality systems require significant financial investment and ongoing technical support. Then there's cognitive overload. If the design isn't right, excessive stimuli can actually overwhelm and hinder the learning process. Accessibility is also a major concern. Factors like motion sickness or physical disabilities can unfortunately limit student participation. This leads to equity gaps, where schools with limited funding may struggle to keep up with these advanced systems. Finally, teacher preparation is vital. Educators need technical training, design knowledge, and new classroom management strategies. Understanding these hurdles helps us build better, more inclusive, immersive learning for everyone. Looking ahead, the intersection of AI and XR is set to redefine learning. Here are some of the most exciting future directions for our classrooms. First, imagine AI-enabled narrative games where plots adapt in real time based on student choices, promoting deeper ethical reasoning and systems thinking. Next, AI could link mastery pathways across subjects, like using reading comprehension from ELA to solve missions in STEM. We'll also see AI assessors supporting peer review by evaluating rubrics and prompting structured critiques, effectively gamifying social learning. Finally, AI will power AR and VR worlds tailored specifically to individual learner profiles and the latest curriculum standards. The future of EdTech is bright and more personalized than ever. As we look to the future, AI-first gamified systems are leading the way, with tools like Dreambox, Duolingo, and Khan Academy. These platforms use NLP and adaptive modeling to create personalized mastery pathways filled with badges and challenges. We're also seeing the rise of Avatar AI, where tutorials are combined with gamified badges and microquests to deliver missions. And with AI co-pilots, lesson authoring is being transformed, auto-generating interactive challenges and assessments. These emerging tools are just the beginning of a more personalized and engaging educational landscape. To truly leverage XR in gamification, we need a strategic approach. Here are 4 key recommendations for effective implementation. First, always start with learning objectives. XR should never be used just for novelty. It must align with clear competencies and measurable outcomes. Second, integrate reflection. Immersive experiences are most powerful when they include reflection prompts, debrief sessions, and peer discussion. Third, use XR for high-value experiences. It's perfect for dangerous simulations, complex systems modeling, or rare real-world scenarios. Finally, blend XR with traditional methods. Immersive tools should enhance foundational instruction, not replace the core of your teaching. Strategic implementation ensures that technology truly serves our learners. In summary, extended reality represents one of the most transformative technological shifts we've ever seen in education. When paired with gamification, it creates immersive environments that align perfectly with constructivist and experiential learning theories. AI and gamification represent a powerful convergence, combining adaptive capacity with motivational architecture to support personalized learning. However, this promise must be matched by human instructional judgment, ethical implementation, and equity-centered access. These are not magic bullets. They are powerful tools that must be guided by theory, evidence, and our meaningful learning goals. Successful integration requires pedagogical intentionality, infrastructure investment, and a deep awareness of cognitive design. XR and gamification are amplifiers, not replacements. They deepen engagement and better prepare students for the world's challenges. To wrap up our series, let's summarize the truly transformative benefits of combining XR with gamification in the classroom. First, we see a massive leap in engagement through increased motivation, and retention is boosted by stronger emotional memory and coding. Skill transfer is enhanced by realistic simulations, all within a safe, risk-free environment for experimentation and mastery. Crucially, it promotes equity by providing access to otherwise inaccessible experiences and ensures workforce readiness through industry-aligned training. The future of education is here: immersive, interactive, and inclusive. Thank you for joining me on this journey.